For this project, the materials that we used were a box, this meter stick, books, a bin of stuff. We used a scale to weigh the box, and then we used that machine to measure the force of gravity of the box, on the box. The first thing we did in our procedure was take the box and fill it up with stuff so that it can add some mass onto it. And then after that, we took it to that gravity measure thing, and we measured the force of gravity that was on it, which was 5.15. And then after that, we created the ramp. And the way we did that was we took the shelf and we put it on top of all these items until we thought the angle was good enough. And then after we got the right looking angle, we took the measurement of the hypotenuse and the height, which the hypotenuse was 86.5 and the height was 34 centimeters. And after that, we just began our math.
Okay, this is a math part to find the angle and then the mu of the coefficient of friction. And so this is a diagram, and then we have to draw a free body diagram, which is right there. And then to figure out the mu, we had to slant it so we can have better view of it. And so it turned out like that. And then to find the angle, we had to use opposite over hypotenuse, which is right here. See, opposite versus over hypotenuse, and we got 23.15. And then you had to standardize it, so we added 270, which gave us 293.15 degrees. And then we had to add that, we had to do the force of gravity in the x direction, which here is the formula: force of gravity times the cosine of the angle. Force of gravity equals 0.422, which is a mass, times the gravity, 9.81, times the cosine of 293.15. So we got 4.14 times 0.39, and it gave us 1.61. Then we needed to find this, the force of gravity in the y direction, which was the force of gravity times sine times the angle, and that's 0.422, which is weight, the mass, times the gravity, 9.81, times the sine of 293.15, 4.14 times negative 0.919, and that gave us negative 3.80. And then we needed to find the sum of the forces in the x direction, and the equation for that was force of gravity in the x direction minus the force of friction equals m times a, but a equals 0, so the equation equals to 0. The sum of the forces in the y direction equals the force of the normal force minus the force of gravity in the y direction equals 0. Then we added force of gravity in the y direction to both sides, and that gave us the normal force is equal to the force of gravity in the y direction. So we plugged it in from what we got over here for that, so that negative 3.80 equals the normal force. So right here, when we got the normal force was negative 3.80, the negative means it was going downward. So then we plugged it into the sum of the forces in the x direction, which is force of gravity in the x direction minus the force of friction equals 0. So 1.61 was our force in the x direction, the force of gravity in the x direction, minus 3.80 mu, which is the force of friction, equals 0. We subtracted 1.61 from both sides, and we got negative 3.8 mu equals negative 1.61, divided negative 3.80 on both sides, and got mu is equal to 0.42.